this video, we are going to see what is common ion effect. To understand what is common ion effect, let us start with an example. Here, first I will consider a weak electrolyte like CH3COOH, that is acetic acid. What it will give me, students? It will give me CH3COO minus and H plus, means acetate ion and H plus ion. If I write its equilibrium constant, K is equal to active mass of CH3COO minus and H plus upon acetic acid. Now this, you know that being a weak electrolyte, it will dissociate to a lesser extent. So this is the first equation what we have seen. Now I am adding another electrolyte to the same solution but having a common ion. What is the meaning of common ion? Having an ion which will be similar to the ions which are formed here. So your next salt what I am adding to this is CH3COO-Na. That is sodium acetate. How it will form the ions? CH3COO minus and Na plus. Now where is the common ion? The common ion here is CH3COO minus. You see this? This is having the common ion. But what will happen because of this? Because of this concentration will increase. When this concentration will increase, the equilibrium constant gets disturbed. And in order to re-establish this, because you know that equilibrium constant or the dissociation constant of any acid or a base is its characteristic property. And therefore, in order to re-establish this, what should happen, student? This concentration should decrease, this concentration should decrease, or this concentration should increase. And so what will happen? That this acetic acid will start combining with this H plus and it will form acetic acid molecule. Means what happens, student? The reverse reaction will take place. Meaning of all this is, whatever the amount of acetic acid has undergone ionization, it will be suppressed. Why it is getting suppressed? By adding another electrolyte having a common ion. This is common ion effect. So what is common ion effect? Common ion effect, of course, it is a phenomena in which the degree of dissociation, that is alpha, of a weak electrolyte is suppressed. How it is suppressed, student? By adding another electrolyte. What type of another electrolyte? A strong electrolyte. I will write this as another electrolyte or a strong electrolyte having a common ion. This is what is common ion effect. So let us understand the example again. Now what will happen here? I have taken a solution of acetic acid. Now acetic acid is a weak electrolyte. So it will dissociate or ionize to a lesser extent. So CH3COOH, it will give me less number of acetate ions and H plus ions. Then you apply law of mass action and write the equation, that is CO minus H plus upon CH3COOH. Now according to this, some amount of acetic acid, it has undergone the formation of acetate ion and H plus ion. So this rate was favored but to a lesser extent. Now I will add another electrolyte having a common ion. This electrolyte is a strong electrolyte. You know that salts, they dissociate almost completely. So it will form CH3COO minus and Na plus. Now what is happening here? The concentration of this will increase in the solution. Right, students? And because of that, according to this expression, this concentration will increase. And because of this increase, directly the equilibrium constant will get affected. According to Le-Chatelier's principle, it must get re-established and therefore this will start reacting with this to give back the acetic acid. Means whatever acetic acid has dissociated, again it will form undissociated molecule. So what this sodium acetate is doing, it is suppressing, right? What it is suppressing? Its degree of dissociation. Why it is doing that? Because of the common ion. Now the immediate question is, what are the effects of this on the solution? The first very important thing is the uncommon ion. Which is the uncommon ion of the weak electrolyte? This, its concentration will decrease, right? If you see this starts reacting, means what is happening? This concentration will start decreasing, and because of that, the degree of dissociation gets suppressed of a weak electrolyte. Now, where this particular thing is useful, so there are various applications for common ion effect. The first and the very important application is what you have in your qualitative analysis. If you see the first group radical analysis, where you are adding H2S plus HCl. So that is the first application of common ion effect. Second application is for third group radical, that is ammonium hydroxide plus ammonium chloride. So there also, which is the common ion here is ammonium, which is the common ion here is H and H. So those are the best examples where you see the effect of common ion effect. So the question is whether this is used in daily applications. So the answer is yes. Where they are used? So the first and the very important is salting out of soap. Salting out of soap. Now what is soap? Soaps, they are made from, or you can say soaps, they are salts of higher fatty acids. How they are prepared? They are prepared by the hydrolysis of, how the soaps are prepared? Soaps are formed or prepared by hydrolysis of oil or fats in presence of NaOH. So what is actually soap? Soaps, as I said, they are the salts of higher fatty acids. So I will write it as RCOONA. How it will form the ions? RCOO minus and Na plus. Now you have to add, this is a weak electrolyte, it will dissociate to a lesser extent. Now what you will add to this in such a way that the common ion should be there or which should be created. So the example the particular thing what I will be adding is NaCl. So let us add NaCl to this. But before that I will write the equilibrium reaction for this. So let us write the equilibrium reaction. So how I will write this? K is equal to active mass of RCO minus and Na plus upon RCOO Na, right? Now I am adding NaCl to it. When I will add NaCl, aqueous, what it will form? Na plus and Cl minus. Now which is the common ion, student? Common ion is Na plus, right? And because of this, what will happen? Concentration of Na in the solution will increase. When the concentration of Na plus will increase, means what is increasing? Is this. When this will increase, this will get disturbed. So in order to re-establish this, what should happen? This concentration should increase. And because of that, Na plus starts combining with this and it will give you back this. Means what is happening? Concentration of this will decrease, it will combine with this and it will form this. So the reverse reaction is favored and thus it gets salted out. So in this way the soap gets salted out. So this is the first application of common ion effect. Here the principle what works is the Le-Chatelier's principle. Let us see the second application where this common ion effect is used, and that is purification of common salt. You know from where you get the common salt is from the salt pan, and it contains a number of impurities. Now this NaCl, the first thing is purification of NaCl, right? So first I will take the saturated solution of NaCl. Now how NaCl will get dissociated, it will give me Na plus and Cl minus. So what I will get here is Na plus Cl minus upon NaCl. Now I need another electrolyte. What can be added to this? Which will have a common ion. So what is passed through this saturated solution is HCl gas, which is made aqueous. So it will give this type of ions. Now which is the common ion here, student? Common ion here is Cl minus. This concentration will increase. This will get disturbed. In order to re-establish the value of this equilibrium constant, this will combine with this. And what it will form? It will form the undissociated NaCl. Now the reaction, when it goes to the reverse side, what will happen? More and more of NaCl or the salt will get formed, leaving behind the impurities. So this is how the purification of NaCl is carried out. The third important application of this common ion effect is in gravimetric analysis to wash the precipitates. Now what are the gravimetric analysis? There we calculate or we find out a particular type of ion present in the given salt by formation of its corresponding precipitate. The best example what I can take is barium sulfate. When this barium sulfate precipitate is formed, then you know that most of the precipitate, they contain some of the water soluble impurities. And so, when the precipitate is formed, we wash the particular precipitate by water so that the water soluble impurities can be washed off. But while washing the precipitate of barium sulfate, we use water which is slightly acidified with an acid having a common ion. So can you guess which type of acid it can be by the time I write the reaction? So barium sulfate will give me Ba2 plus and SO4 2 minus. If I try to write this equilibrium reaction, it will be 2 plus and SO4 2 minus upon BaSO4, right? This is the expression. Now, if you see here, you can make out which type of acid, or I will acidify the water with H2SO4. So, the other electrolyte what I will add is H2SO4. It will give me 2H plus and SO4 2 minus. Now, which is the common ion here is the sulfate ion. Now, what will happen is this sulfate ion concentration in the solution will increase. Because of that, this will get disturbed. In order to re-establish this particular equilibrium constant, what should happen? This should combine with this and it should form barium sulfate back. Form barium sulfate back means what? It will keep that particular precipitate here and it will not get washed up with water. So the precipitate will remain on the filter paper and the water soluble other impurities will get washed off. So this is all about common ion effect. Common ion effect is a phenomena in which the degree of dissociation or ionization of a weak electrolyte is suppressed. How it is suppressed? By adding another electrolyte. Which electrolyte? A strong electrolyte having a common ion. And it works on the principle of Le Chatelier's principle. Application is salting out of soap, purification of common salt and washing of the precipitates during gravimetric analysis. So this is all about common ion effect. Thank you, students.